Hello everyone, this is Team Antonia. We're going to cover the topics input devices, user interfaces, and VR environments. I'm Dhiren Raj, and I'm going to talk about the topics about input devices, and these are the other topics we're going to cover in this presentation. So moving on, so input devices. We know like basically all the input devices like the keyboard, mouse, the devices used to give the input to the system. So we are classifying the input devices based on their functionality. So each input device can be used to give a specific kind of input. So based on their functionality and the data type, the logical input they can provide, we divided them into four kinds of devices: locator, stroke, choice, and picking devices. So speaking about the locator device, so these devices are usually used to give the coordinate position of the cursor. So we place the cursor on the screen. So uh, it these devices give out the location of these cursor positions. So we can use mouse, touchpad, joystick, trackpad, and so on and so forth. You can also use a light pen as a locator device, but it needs an extra implementation since it works from the light produced by the screen. So you just need a little extra implementation. As you can see, these are the common devices that fall under this category. And moving on, we have stroke device. So a stroke device is something which is similar to located devices, but the key difference is the stroke devices uh, give us a series of coordinate positions across the screen. Uh, it is like a continuous, uh, all continuous coordinate positions, say from point A to point B. And we can use this, like it can be activated through a button in the tablets. Usually the paintbrush is a good example of this, of the stroke device. So this here is a very good example of stroke device. Here we can see that uh, you can draw, you're drawing on a graphic tablet, so starting from point A to point B. So this is taking in a series of uh, input coordinate positions. Okay, so this is a stroke device. So going to choice devices. So choice devices are mainly used to choose. You can get that by the name. So there are like a lot of options like in a menu. So choice devices are usually used to uh, traverse through a menu and choosing an option. So let's say the menu's domain or horizon is from xmin, xmax, and ymin, ymax in terms of the boundary of the menu. And if the cursor position, say x comma y, is in that domain, so it qualifies to choose that option. So this is the condition that it should satisfy so that it can choose it. So yes, uh, we can use a mouse, keyboard. When it comes to keyboard, you can use the arrow buttons to choose the menu options, and even the touch screen, like we can use our own hands to uh, choose the options from a menu. So a touchscreen panel is like the latest example for a choice device. So picking devices. A picking device is something that we use to select in order to transform or edit it in some way. Select an element, I mean. So this action can be performed with a cursor, button, keyboard, joystick, etc. So basically what we're trying to do is, let's say there are a lot of elements on a screen and we want to pick one of those elements. Like we want to select that element so that we can edit or transform it. So then these devices come into play. So there are like a lot of methods and schemes to pick certain elements on the screen through the picking devices. So there are like a lot of methods, and we'll be discussing about them right now. So the first approach is called the cursor positioning approach. So cursor positioning is, let's say you position your cursor on the element you wanna pick. Okay, so if the coordinate position of the cursor and the element are aligned to each other and produce the same coordinate position. So I mean, if the coordinate positions of the element and the cursor fall in the are the exact the same, then we can pick that object. Okay, so that's basically the cursor positioning approach. And if the pick position of the object, say the cursor, has a lot of elements just around it, around the element we want to pick up, so if there are like a lot of elements, so it's too crowded for the there's been a lot of overlapping for the cursor position and the element position. So then this test fails. The coordinate position test fails. So if in these situations, if the coordinate test does not uniquely identify the pick object, we can use a formulation, like we can get the perpendicular distances from the elements from the cursor position. So here we have the cursor at x comma y, and these are the two line segments, for example, and we can take the perpendicular distances from these line segments, and we can calculate the perpendicular distance with this formula. And this is in case if the pick the coordinate extent test fails. So in order to decide which object we want to pick, if there's like a lot of more than many objects or elements are there, we can use this approach to pick the object. So this is a second approach, picking window approach. So picking window. So we can form a window around the cursor position with length h and w, with height h and w, sorry, with height h and width w. So when we form the cursor window, any object or element which falls in this window or intersects or falls in this window will be picked. So we can form a window like this around any element or object we want to pick. So for example, say we are picking up a line, and we just set a small window of width, height, and h, with w and height h, so that the line, just the one line segment intersects that pick window. Okay, so that's the pick window approach. And moving on, we have a highlighting approach. So in the highlighting approach, what we basically do is we highlight a series of objects. Like say we highlight most of the objects we want to pick, and from that the user is given a choice to reject the objects he doesn't want to pick. So let's say there are like a lot of elements on the screen, and he only wants to pick up like just 8 out of 10 of them. So what he can do is he can highlight all of those at the same time, and he can just use accept or reject action for the highlighted object, so that he can just pick for the objects what he wants successively.
Hello, my name is Shilpi, and today I'll be discussing few topics related to computer graphics, and first one is computer modes. first computer mode that I'll be discussing is the request mode. So the application enables a device and then wait for the user to trigger input. It is basically similar like we get the user input from the console, or it's like we give the input command in Python to get the user input. So here program will wait until user enter the input, and you is the user who decides how long he or she wants to take to insert the input. So user has a power to stop an application as long as the user wants. In sample mode, input is actually immediate. Application can measure the current value of a device, and user don't enter the inputs in this mode, and the program usually retrieves the values from the file or the location or the buffer. So retrieving the current location of the cursor is just one example of the sample mode. Another one is the event mode. The application here can enable several set of logical devices simultaneously, and each device can trigger an event at arbitrary time by a user. So each trigger generates an event, and all these events will be put in the event queue, and that can be examined by the user programmer. So all the events will be generated based on their position in the event queue. Next topic is interactive picture generation. So now we see there are many techniques which are added in the software packages to make the picture generation interactive. Various input options are also provided so that coordinate information entered with the locator and stroke devices can be adjusted or interpreted according to the selected option. One way to do it is the constraints. So it is the rule for altering the input coordinate values to produce a specified orientation or alignment of the displayed coordinates. One example for that is drawing a horizontal or vertical straight line. Suppose we click the mouse at point A on the screen, and then we release the mouse button at point B, so there will be a line between A and B instead of the jibber jabber movement, instead of drawing the jibber jabber movement of the mouse. So this is a constraint. Next is the basic pointing method. So here the position of the cursor on the screen will be used to draw a shape or insert an image or insert a text. So this is a very common method in nowadays. We can see it in all the GUI softwares like in Paint, Photoshop, and even in Google Slides we are using the same technique. Rubber banding. Bending is a very popular technique. This is like a de facto standard in the GUI for drawing, and it's almost accepted by all the Windows-based applications. So actually how it works, so the user moves the cursor to appropriate position and then selects, and then as the cursor is moved, the line changes, taking the latest position of a cursor as an endpoint. As long as the button is held down, the state of a rubber band is active. As you can see in the picture, first is neutral. When we press the button, then it will enter into a rubber band mode, and we can move the cursor there, and the moment we release the button, it will again go back to a neutral state. So this is the example of drawing the lines using the rubber banding technique. First image shows the initial position, and then second and third is showing the intermediate state when the button is pressed, and the last one is showing the final line after releasing the button. Same is for drawing the rectangle. Here we started with the bottom left corner, and then we draw a rectangle, and then in figure D we can see the final output. Same goes with the circle, so we are drawing the circle, and then the figure D is showing the final output. Same goes for the curve. So let's see how the Photoshop used this rubber banding technique. Let's go directly where it is starting. So here the user select the rubber band and then it's trying to draw a line, and then the moment it draws line 1, the moment it's release the mouse button, and then now if you can see it is drawing a curve. So that's how softwares, GUI softwares are incorporating this technique. You can see how and see how it is changing the shape, and this is the pen option that is user selected in the Photoshop. Next, let's talk about virtual reality environment. This is a very nice topic, and the important terms here are input devices and interaction techniques. So input devices are basically just the physical tools that are used to implement various interaction techniques. There are many different techniques available, and all can be mapped to a one single input device. So it's like many to one relationship. So classification of the input devices. They are broadly classified into four. First one is the discrete. So discrete is like we are generating one event at a time. So like pressing the key of the keyboard, it will generate a boolean value, whether it's pressed or not, is true or false. Same with the pinch gloves. So whenever we pinch the two fingertips, it will generate a signal as a boolean value that we pinched it. The moment we release the fingers, it will regenerate 0. Second one is continuous. So as the name suggests, here there will be the continuous input generated, a continuous stream of events in isolation or in response to a user action. So these inputs can be generated either by the user or can be generated automatically. One example is the tracker. So I don't know if anyone sees those old mouse where they have the ball at the back. So those are the trackers. They continuously output the position and orientation whenever we are moving that. And the new cool example of that is this is cyberlink. So here we are getting the input as a eye movement, facial muscle movement, brain waves. All these are generating the input signals, and all are used to produce the outputs. Hybrid, as the name suggests, is the same as combination of input devices. Hybrid in the combination input device combine of both discrete and continuous events generating devices to form a single device that is more flexible. Example. The standard examples are joystick and mouse, and the complicated one shows the space mouse. So space mouse basically has 60 degree of freedom. So it can take input from the slide pressuring the fingertips on the, and it will end a bit of a deflection in the XYZ coordinates, and which will generate some movement in the 3D space. Most interesting one, and which we see nowadays, is the speech input. So this is actually a natural way to combine different modes of input to form a more natural interface. We can see nowadays with Google Echo, with their phones is Siri, then Alexa, all these are taking speech inputs. So the speech input can be a valuable tool in the VR environment application, especially when both our hands are occupied. Suppose we are playing the game and both of our hands are occupied, then we can give this speech input and we can do a task there, giving the instructions by talking. So it is ideal for multimodal instructions. Obviously, we can give multiple instructions in using different modes. So this is a perfect candidate for that. This is most popular in the case of gaming because the player is using both the hands, and then it is giving instructions to the machine to take left, right, or increase the speed and whatever it is. But the problem with that is, suppose there are two people, two users who are talking with each other, then when the machine will think that this is an instruction for the machine, or they are just communicating with each other. So simply we can say now with the Siri and with Google and Alexa that we use a keyword like Alexa, play some music. Siri, what's going on in the world? So we are using keywords to differentiate it. Also, we have to put the mouthpiece. If we put it far away from the mouth, then there will be too much noise. If we put too near, then we have to create something sophisticated which is screen friendly, won't get user won't get any rashes, it's not too hard to the skin, and then if we put it in the mouthpiece really close to the mouth, again there will be too much noise. So some noise cancellation technique should be used. So these are few of the challenges in speech input. Next is classification of virtual reality interfaces. First is the feedback center interaction. So basically it's a one-way thing. It's like one dimensional. The machine is getting the feedback and they're showing it as it is. The example is ECG machines. So they are taking the signals from our brain and then tracking those, and they're showing it in the machine that zigzag with exact signs. Next is the gesture-based interaction. So here the user makes some gestures like movement from left to right, right to left, moving hands up, moving hands down, and the machine will understand this and take it as an input. So this is a very common way to do it, and this is a very common way, and people are using it to play the online games like Nintendo is using for tennis matches. So user hold that small stick and then the user move the stick left, right, top, bottom, and they can play the game like that. Another way it is using in healthcare also. It helps in tracking the patient's movement. Suppose someone break the leg or hand, then they can attach the machine to the hand or the leg, some diodes or some device to check the movements, how it is and how good or how bright it is, if whether the movement is showing any problematic area. Suppose some vein swelled up and vein is not working properly, then they can get all those values with this gesture based interaction. So you can use it for fun or you can use it in healthcare. It's your choice. Another is haptic simulation based. I think everyone has experienced the all those 7D movies, 11D movies, D-Box movies. Everything is based on these kind of interactions. So it's like, suppose something is happening on the screen, and if you're watching a movie, an action movie, and suddenly a car drop on the ground, and then there's a thud, and it's like the moment, and suddenly your seat also rotate like that. And if you watch in the 70 movies and in those amusement park, if some wind is going on, then you can feel the wind coming on your face or some splash of water. The most amazing example or feature that I felt it with myself is I was sitting in this stimuli, which is for the roller coaster, and I'm wearing those glasses, and this is that rotating chair that I'm sitting in, then with the glasses and the movement, the way I'm moving there with the hands, They give me the steering wheel and the way I'm moving it. My car, my seat is rotating in that way, and the wind is coming in the same way, which is a really cool experience. So that's haptic. Now let's talk about the display methodologies. So it is created with the intention that the viewer interact with and experience the content instead of just sitting back and to watch. That's the real motive behind the virtual reality environments. So by nature, all the virtual reality videos are shot in the way that let you see the 360-degree around you. So watching virtual reality can make you feel present in the action of the scene because you must cover your with to get the feel, you must cover your entire field of vision with the viewing device like headset or HMD. When you look into the HMD, the screen is split so that each eye sees a slight different perspective, just like in a real life, because our left eye perspective and right eye perspective are a bit different. So this gives the sense of reality, and this is the key element that distinguishes VR reality from 360 and other type of videos. The interesting one is the cave. So it is a room. It is a room which is where walls are typically made up of all the projector screens, and the floor is also there are downward projector screen or a bottom projected screen or a flat panel screen. The point here is that the projection system are very high resolution due to the near distance viewing, which requires a very small pixel sizes to retain the illusion of reality. So suppose, let's take the example of the forest. So cave is depicting a forest, so all the screens are showing the trees, the plants. So when we are moving in the cave, we feel that there is a rock, and when we go at the back of the rock, we are seeing some small tiny leaves, some grasses there, or small flowers are growing somewhere. So we can take a close look. For that, very high resolution is required. So the user usually wear 3D glass inside a cave to see a 3D graphic generated by the cave, and people using the cave can see objects apparently floating in the air, can walk around them, get a proper view of what you feel, what it looks like in reality. So suppose there is some cave where you are in the water and fishes are floating around you, so you can see that fishes are floating around you. It gives a real experience. And that's the motive behind all this virtual reality. It gives you the sense that you are actually there. So in cave, the user's movements are tracked by the sensors typically attached to the 3D glasses the user is wearing, and the video is continuously adjusting to retain the viewer's perspective. Computer control the aspect of the cave and the audio aspect. Here audio is very important to give the real feel. Suppose let's take the example of the forest again. So the user is walking where they between the plants or the grass or in the field, so it will be brushing off so the nearby trees and bushes, and this will make some noise. So the speaker should be placed at a proper angle so that the sound is perfect and it feels like you are actually moving and crossing the field. Now visualizations. So visualization is a very trendy topic right now. Everyone try to visualize everything nowadays, be it data, be it any illustration, anything. So virtual reality data visualization is basically computer generated, it's highly interactive and 3D projects. VR is actually the future of the visual industry. Everyone wants to see all those 3D models, and industry is utilizing various animation and rendering software in conjunction with the VR platform to deliver the entire new way to experience a design project. VR visualization has the potential to offer easier pattern recognition and attention. They also feature different perspective beyond the 2D images that we are familiar with. Yeah. We are talking about 2D, 3D, adding interactions that we'll see later on in the examples. As you can see here, this is the Brexit. So everyone know about the Brexit. It was such a big, huge talk. So Google Labs created one illustration for that. What they did is they get they just find out the most searched line or most searched story country-wise in the Europe. So it will goes to the different country and then it will show it there. Firstly in their mother tongue and then it will convert it into English. Like you can see in Germany, it is showing why does the UK wants to leave US is the most searched topic. And next one is the visualization given by the fusion. It is a blue whale experience, so I'll play the video and show how it actually feels like. It will tell you how you feel when you are swimming next to the whale. So if you're wearing the glasses, then you have to move your eyelids left and right and you can see it. See, we can see the view where it is. This is the bottom, this is the top. This is the closer view, how it will look like. And there's the skin, how the whale skin look like. That's what they're explaining in there. So you see, we can get the all 3D view. We can see all the 360 view. This is really amazing, I must say that. And here's another visualization. It is showing the 21 years of the NASDAQ. It's by the Wall Street Journal, so they are showing all the important things that happened there, like index price earning ratio and what happened, which crisis came in which year, what are the major landmarks. And this is my most favorite one. It is showing the Pluto. This is by the New York Times and this is really amazing. One has to watch this. And here comes the ad that we cannot stop because it's YouTube. This is gives a view. How actually so there is a link. If you want, you can watch these videos by yourself and enjoy. And that's all from my side. Thank you.
Hello everyone, this is Ajit Raja. So today I'm going to talk about graphical user interface. So GUI is a form of user interface that allows users to interact with electronic devices through graphical icons. The actions in a graphical user interface are performed through direct manipulation of the graphical element. So let's consider this paint window. So to increase the size of the window, we will be dragging the corners of those windows to increase the size. And to zoom the pictures in our smartphones, we will be using direct manipulations. GUI. Normally into a GUI, our input will be in the form of through the keyboard, mouse, microphones, or through touchscreens, and we will be giving our input to an electronic systems such as computers, smartphones, or any other electronic devices such as smart printers or something. And our output, we can see our output in a GUI such as screens, or we can get some other different form of outputs. And Windows is an area on the screen that displays information with its contents being displayed independently from the rest of the screen. So there are 5 different types of windows. They are container windows, browser windows, text terminal windows, child windows, and message windows. We'll be seeing those windows in the following slides. Container windows. Container window comes into play when we open a repository. This container window shows all the contents inside the repository and even the executable files. Browser window. Browser window allows user to move forward and backward through a sequence of documents or web pages. So our web browser is a browser window where we can just move forward and backward through a series of web pages. Text terminal. Designed for interaction with text user interface within an overall graphical interfaces. So this command prompt is a text user interface which is in the graphical interface. Child window. A child window opens automatically or as a result of user activity in a parent window. Example, pop-up windows. Pop-up window contains a menu of commands and stays on the screen until you select one of the commands. So we all know about the annoying pop-up screens which we get when we are browsing on the internet. Those screens, they just stay on the screens until we close them. Message window. They are basic windows opened by a program to show some information to the user or to get some information from the user. It makes sense to use a dialogue in a situation where you need the user to interact before continuing more or when the cost of error could be very high. So let's consider a scenario where a user is deleting a large set of files. It is good to have some confirmation with the user before deleting. Menu. Menu allows user to select from the list of choices available. Menu limits the amount of documentation the user has to read to understand the software. So let's consider these images below. So this in a window container, the menus will always be on the left side, top left, and these menus gives a list of options for users to select it, which avoids the user to read the documentation. So just by reading these names, the user can get some idea. Icon. An icon is a small picture that represents objects such as a file, program, or web pages. Normally, to open a repository or run some applications, there is no need for us to type some commands or run it. We can just select these icons. By double clicking it, we can open them. Skill levels. We should design our software for different group of users with different skill levels. There may be user who is expert in the application, or there may be user who is in beginner level, and there may be users who knows something about it but not to extent where they can fully function on their own. But mostly 80% of the users in any application, they belongs to intermediate level. Beginners. A beginner is someone who has little or no experience with the product and thus may not know how to complete the task. If the user interface is not easy to understand, or if the user interface is a bit complex to those users, then they may shift to a different product. Certainly not everyone, when they are buying a new application, they won't go into the user manual and read it. They will just open the application, they will try to learn on their own. So if the user interface is a bit easy to learn, then those people may continue on our product. Intermediate. An intermediate user has used the product for some period of time or may only use the product at rare occasions. However, the intermediate users may not have explored all the product's functionality. In such a scenario, these tooltips will be very useful to all kinds of users. So let's Consider this image. So if you are pointing the cursor to some menus or icons, there will be a small rectangular box saying that contains the function of the menu that which the cursor is pointing to. It will be very helpful to all kinds of users. Even experts may find these kind of tool tips helpful at sometimes. Experts, though their number is much smaller than intermediate and it's probably even smaller than the number of beginners, this is a main group of people we have to consider. Whenever we want to use some new applications, we will be asking experts for their suggestions. And these experts they tend to do some rare complex scenarios where they will require shortcuts or significant customizations. We should provide those shortcuts and significant customizations so that these people they can do their complex queries or something. Consistency. So whenever we are designing an user interface, we should maintain a default template for the whole application. Let's consider a scenario where we have to assign some particular icon to some functionality. We should maintain the same throughout the application so that it will be easy for the users to process. And we have to have some similar looks and layout for all the windows and use same font for similar level of abstraction and general convention for menu orders. And both Windows and Mac have their own default user interface template for all their containers. Below is an example of a default Windows container. So in a Windows container, the minimization, maximization and the close buttons will always be on the top right corner and the menus will be on the left. So this is pretty much a default template for the Windows container, which makes it easy for the user to understand so that they don't have to memorize where those close buttons are, or they don't have to look for those buttons. They know by default those buttons will be on the top right and those menus will be on the top left. Minimizing memorization. Icons should be easy to recognize so that it will be easy to remember. Select clear names for the actions. The user should be able to recognize rather than recalling. Undo and error handling. A system should permit commands or actions to be reversed. Current system set should be stored in case of a user or system error. Error always happens. The user may do some mistakes. The user should be always be able to revert back to the previous state so that the machine can continue from there on. So when the user is making some major changes or when the user deletes something, there should always be a notification message to the user stating about the severity of the error, or like if a user is deleting a big chunk of files, there should always be a confirmation message from the user to delete it. Designers should assume users are unable to understand technical terminologies. While giving some info to the user in the dialog box, it should be in a way like users should be able to understand the terminologies so that they can try to solve the error by themselves. Feedback. So normally when an application when the user tries to run some applications or try to install some applications, there should always be an acknowledgement to the user about the status of the installation. Likewise, when the user uploads the image, there should be always an acknowledgement that whether the image uploading the image is successful or not, or something like that. So consider this image. There is an error saying like Windows system error. There is an IP address conflict with another system on the network. Not everyone knows about IP address. So to make all levels of users understand about the error, the notification message should be in a way which makes the user understand the severity of the error, which in a way can help the users to solve the error. In this image, the user interface asks the user for some zip code. Formatting these inputs can be done at the back end. There is no need to ask the users to type everything in caps. We can save this. We shouldn't make our own problems the user's issue. Thank you.